Links sort of to resources and stuff in this presentation. So if you're, I'll show the slide at the end as well, but if you're interested, the short link to it is here. So a little bit about how I got started. This is one of my first ever educational workshops that did use a bit of open source hardware. This uses an Arduino inside it. It's a wind tunnel that lets kids build wind turbines out of recycled materials and then test them against each other to see what shapes they can build to get the best power out of it. And we ran that as a competition for quite a while. This was something for Hackney City Farm, who wanted a bicycle-powered cinema. And this is one of the things that really got me into open source and the importance of documentation in open source. So I wanted to make something that these kinds of things, they're interactive exhibits, they get used, they get hammered a lot, they break. So I didn't want to always be the person on the end of the phone. I kind of did it out of reasons of laziness. So I made sure that everything was labeled clearly inside, and it had a web page that you could go to that explained it with the schematics and the circuits. And I think that one of the key things that I'm going to be coming back to during this presentation is about the importance of good documentation with open source hardware or software in terms of making it useful and usable. It's no good having something that is great, but I can't work out how to use it or someone else can't maintain it. This is my most recent open source hardware project. I got given a few thousand these big LEDs, so I decided to make some really big displays out of them, mainly so that I could make a really cool badge. Which has also got a Raspberry Pi in it, which is totally ridiculous. So this is just a reaction timer, so it meant the batteries ran down really quickly, but it was for a Raspberry Pi event, so I thought, why not do some wearable tech with the Raspberry Pi? Totally useless. It was really heavy and runs out of batteries really far too quickly. This is a really interesting project. Demand energy equality. I'm in Bristol and these guys are based in Bristol. This is a solar panel tree, and they wanted to link this up to the internet, and we solved that with a Raspberry Pi. So that was my first professional project using the Raspberry Pi to solve a technological challenge. We wanted to, he was really, it wasn't just to make it look good, he wanted to understand about how solar arrays can perform differently. Like the normal thing is just to have them all facing one way, and if you're clever then make them tilt. But trees don't have all their leaves facing one way, so he thought maybe he could do some tweaking or get some more interesting results if he had them all pointing in different directions. So a lot of information's coming out of that. That's all being logged by the Raspberry Pi onto I think we used COSM, which then changed to Xively as an Internet of Things logging system. And that also plugs into a data visualization service that I've been working on. So this is the size of the leaf. One leaf gets drawn every 10 minutes, and the size of the leaf is representative of the amount of energy that was generated, and this was generated on May the 7th. So that is plotted on a website that can then be embedded as a different way of understanding energy usage. So the way I use Raspberry Pis now is mostly in educating teachers. So there's probably quite a few of you know that the curriculum has changed a lot recently, and now we need to be teaching computing and computer science. Probably a lot of you guys are quite excited about that. I'm not sure if it's such a great idea to make it compulsory for everybody, but it's really good that a subject that used to be completely bankrupt of content, that was always the kind of the subject that anyone would do if they had a few hours in their timetable, now has some real good stuff in it. And reading through the curriculum as a professional computer engineer as well as a teacher and educator, I'm really pleased that when we're working with teachers, we're training them on a syllabus that makes sense, that is useful, that is going to enable and empower kids to do useful things. And one of you probably know these logos already: Python, Raspberry Pi, and Scratch, the graphical programming language. But one of the key points that Scratch is all about is about turning kids from being digital consumers into digital creators. And there's this kind of urban myth that all kids and all young people are really excellent at using computers, but really they're just very good at consuming digital media using iPads and phones. Most of them are just as helpless as the rest of us when the Wi-Fi goes down. And Scratch, one of the key things in their creative curriculum, and if you're interested in teaching younger people, then Scratch is a great tool to do that, and they have a lot of resources, and they've got a creative curriculum, and one of the main points is about empowering kids to be creators rather than just consumers. So we run a bunch of courses with teachers. That's been really fascinating. It's put me into a room with a lot of teachers. We get some people that did computing 10 years ago. We get some people that have just graduated. We get some people that they were teaching ICT as it used to be because they were the person that managed to fix the printer in the staff room, or because they had 2 hours spare from teaching PE. And now all of a sudden they have to be teaching Boolean algebra and the kind of the deeper details of computer science. And these, sometimes we have, I've got a few slides here. So this is, you've probably seen this if you're used to using SSH into other computers. PuTTY is what you use typically on a Windows machine to log into a Raspberry Pi remotely. And everyone gets confused that they don't see the password because we're so used to using often Windows. When you type the password in, you get the asterisks come up to tell you, but Linux is a bit more security conscious. So it doesn't matter how many times I say before we start this program and give the warning, you won't see the password, we still get people, it's not working, why doesn't it work? Because they can't see the password. We've had lots of people who don't know the Alt key on the keyboard, so I'm telling them to type in a specific command, or when we're teaching a bit of the command line, people are so unused to using their hands. We're in this really point and click world, just with a hand, just with one mouse, with one finger. But it's great doing a bit of command line stuff, because it's quite easy to show its power, and it's quite easy to draw parallels. So it's annoying to type in a lot of long-winded commands, but if you get them into tab completion and make the metaphor of text autocomplete on mobile phones, that really pings people, and they go, oh yeah, that's really great. And if you can say, you can write a little loop on a command line that can process 1,000 images in 5 minutes, it would have taken you hours pointing and clicking, which is what first sold me on the power of command line, then you can get people interested in knowing where the Alt key is. Fantastic. This is how we used to have to create SD cards. So when you buy a Raspberry Pi, you don't get an SD card. And I'm used to doing disk images and ISOs and stuff like that. And I used to use CD writers when you still had to use these kind of annoying imaging programs. But it's something that most teachers have never come across, having to make a disk image. And instead of just copying files across, like you would expect to on an SD card, you can't do that because it's got to be Linux formatted, so you have to copy an ISO across. And this took us about 45 minutes every workshop, something that really should only take 5 or 10 minutes. But it's surprising how, like you pointed out in your talk as well, there's these little bits that you don't expect to be complicated or particularly a challenging point, but they often are. So this turned into, and takes a lot of time, so this turned into, there's a new system now, if any of you guys have Raspberry. Who's got a Raspberry Pi? Who uses it? Oh yeah. Who's a teacher here? Who works teaching in education at all? Okay, well I hope some of this is useful anyway. So they changed this imaging program into something called Noobs, bit of a dodgy name, new out-of-the-box software it's called. And you can just copy a file onto a FAT32 formatted SD card. When you put that in a Raspberry Pi, it lets you install the operating systems you want. Great. So that only takes us 5 minutes now. And I think that's a nice example of one of the things I want to focus on or touch on this talk is how one of the great things about using open source software is that it goes really deep. You know, you can use the command line just occasionally when you're copying out some instructions from a web page that tells you how to install a module or whatever, or you can get really into it and use it all the time. But even if you don't use it, it's still there. You've still got access to it under the bonnet. There's this incredibly powerful engine. You can still do installation of the software the old style way, or you can use Noobs. But Noobs lets you save a lot of time and get into it quickly, like you mentioned in your talk about sometimes you don't want to spend all this time. I don't want to spend 45 minutes telling teachers how to copy an image onto an SD card. That is a waste of time in a very strictly time-limited workshop. So there's definitely a case to be made for making your stuff look and feel good and easy to use and documenting it well. But one of the great benefits of using open source software, especially stuff like Linux, is underneath you've got this incredible power that you can always go back to that you don't often get if you're not using that kind of software. Quick note about Tiffin, fully branded today. So through our work with teachers, we came up with a couple of little innovations, some really simple ones like putting the GPIO pin header directly next to the place where you need it, so you don't have to have another printout next to you that you're continually referring to. This is released in the public domain under Creative Commons, so if you've got access to a laser cutter, you can cut one of those files, or you can buy one from my website, tiffin.co.uk. I forgot to, one of the nice things about, how do you zoom in and out on this? No, oh well. Few words on resources that are really useful for teaching with Raspberry Pi. Has anyone heard of Sonic Pi? No, it's like, it's based on Ruby, and it's a way of programming for sound. So you can load up samples and you can load up synthesizers, and you can do, version 2 has just been released. There's the CAM Jam, the Cambridge Raspberry Pi Jam a few weeks ago. They recorded all the talks, and someone did a talk about this. So if it sounds interesting, check out his talk, because he does a great demonstration of what you can do and builds up kind of this live synthesis stuff. And it's really appealing for kids, and there's a great set of lesson plans that are released on a Creative Commons license. And it was having access to those materials that really inspired me to create this website, turtleprize.com, where we use the Turtle default library of Python, which lets you get kids drawing graphics on a computer screen straight away. So I'm always looking for ways of getting to that point where you can get a child excited about something as soon as possible. So being able to draw something on the screen in kind of 3 or 4 lines of Python is a very easy way in, and then you can say, okay, now use these little bits of code to draw out your initial or something like that. So we run a prize and give away Raspberry Pis and stuff like that to the best pictures submitted to our Turtle Prize website, and we've got 3 lesson plans in a mini scheme of work. So if you do know any teachers who are looking for Key Stage 3 stuff, send them this way. It's all free. Most recently, I've been working on a really fun workshop that uses Raspberry Pi and Scratch and Arduino and stuff like that. It's for Hydrogen Island, it's been rebranded now. It used to be called Eco Island, and it's about using hydrogen electric cars on the Isle of Wight, and they wanted educational stuff to go along with that rollout. So I was commissioned to build a workshop for Key Stage 2. And this is me here at the end of a pink string. We made this great workshop that involved a bit of science, where they calculated how big a volume of hydrogen they'd need to float a little payload that had a Raspberry Pi on it. We taught them a bit of programming, a bit of Scratch programming. You can run Scratch on the Raspberry Pi, and it's got a GPIO plugin that lets you control LEDs and things like that. And I wrote an extension for that lets you use the Raspberry Pi camera, which is another great example of make your stuff easily editable and open source and document it, and then people like me who want to be able to do something with it can easily make this extension and then make it available for other people. So this is taken by a Raspberry Pi that's running a computer program that the kids program themselves, and that's one of the nice things about using a Raspberry Pi, is that we could just plug it straight into the teacher's projector and show them this computer that they could also see and was light enough and cost cheap enough that if I let go of the string, it's not the end of the world. You can do this, the more fun versions is where you do let go of the string, but then you have to have a budget to hire a van to track it down and a GPS and stuff like that. So that's more of a later on workshop, and it kind of costs like £500 or £1,000 per run, so you can't really do it that often. Whereas, although this one is special because it's running on hydrogen, which you wouldn't normally do unless you were being paid to tell you how good hydrogen is to run your electronics. We're working on a helium version that we're going to be selling the kit of on Tiffin as well, and we've got the weight down so that 1 tank of helium gas you can buy for balloons is what you need for running an hour's workshop. So that gets the workshop price down to kind of £25 per run. So that's really doable, and we run this workshop in 2 hours. So it's a really doable thing that lets you cover science and maths and computing all in one workshop. And the kids went wild at the end, which is great. It's really good fun to run. This is a close-up for the geeks. Raspberry Pi. This is a 1.5 watt fuel cell. This is another bit of open source software and hardware. I was commissioned to make that by Arcola Energy. That's like part of a fuel cell inventor kit. So that's the fuel cell controller that runs the fuel cell, and then we can take the wires and power the Raspberry Pi from the hydrogen that's in the balloon. And this is the Scratch program that the kids write in order to make, it's essentially a time-lapse program, just in a loop, taking a photo, broadcast photo, that's how we do that. And then these broadcast pin 8 high and pin 8 low is what flashes an LED, so you know when to pose. The blue light comes on, and then you strike your pose there. So we print this stuff out on big bits of paper and get the kids to assemble it on their class, because you can't always guarantee that you're going to have access to an ICT suite. But if we bring along our bits of paper, they can juggle them around, and you can start talking about sequencing. And we play a physical game called Program Your Robot to get them into the idea of programming if they've never done any sequential programming before. And that GPIO extension for the Raspberry Pi is available here from a guy called Simon Walters. One of the things that I've been really interested in doing all this work with teachers is this possibility for me to really study how people learn computer programming, especially complete beginners. And I was thinking it would be great if I could track things like lengths of program and whether they compile or syntax errors, and be able to see that in real time, and then also be able to fade forwards and backwards and track code, and to look at how people progress over an hour. I'll be able to quickly see who I need to go to and have a look to see if they're... Because when I'm programming, I'm making errors all the time, and my programming is failing and then working and failing and then working. I thought that if I could track that, I'd be able to see as the number of lines progresses, I'd be able to plot that. So these lines here are lines of code as it increases, and then if it's green, it means it's got no syntax errors, and if it's white, and so this guy has got to a point, made a problem, and then his program hasn't worked, and he's not done any work on it. He's not added any new lines. He's not tried to fix it. So maybe that's someone that I should go and say hello to. That's actually a fake person anyway. But this is a tool that I'm working on at the moment for use in running workshops, and it's really, really simple. Kind of 100 lines of it is generating a nice graph, and then there's 5 lines of it that's a cron job and git. So it runs really easily and straightforwards on your Linux machine. So this works great if you're teaching with Raspberry Pis, but I don't know how you would do it on a modern classroom that's stuffed with Windows computers. You'd have to do a bit of work on that, and that's another reason why it's great to be using free open source software. So if you're interested in that, if you want to get involved, that's on Git, that's the link there. Another nice example that I often share with teachers when I'm talking about, because a lot of teachers haven't heard of what open source is or free open source software. And one of the things why I say it's good is all these teachers, they know they're going to have the guys at the bottom of the class that are really struggling, but they're scared of not knowing what the guys at the top of the class know. And they're terrified that they're going to run out of material. One of the nice things is that if you do get people that are really going for it, and there are those kids in classes, you can point them at the code that is running the systems that they're using. So you can say, here is the Linux kernel, this is how it works if you want to understand it. One of the examples I do, when I'm running a class full of Raspberry Pi stuff, I set the act light here, one of the LEDs you can control, the only LED you can really easily control on the Raspberry Pi that's soldered onto the board, and have that running a heartbeat so that it's flashing. And if it's flashing, then I know that Raspberry Pi is booted. But I didn't really understand why some of them were flashing much faster than others or slower. So I dug out the code and found out that it is meant to act like an actual heartbeat, and that is I don't even need to understand C. Someone has commented their code nicely enough that I can just read that and think, oh right, it's actually, the harder the Raspberry Pi is working, the more faster this heartbeat is flashing. And this is an excellent example of why it's great to be using open source software, because you can point this stuff out. You can point the source code to Python, you can point the source code of the Turtle library, of Linux, to your really outstanding what do they call them, gifted and talented students, and they can learn C by reading some of the world's best software, like this amazing operating system that runs half the web, just there, and what an amazing resource. And if you've ever done any reverse engineering, like I've done, this is a bit of reverse engineering on trying to control a thermostat by an undocumented radio thermostat, you have to go to such lengths to be able to get anywhere and spend so much pointless time trying to, this is using a software-defined radio to pull stuff off the air to then try and work out how they're arranging their send and end bytes and what checksum they're using. It's a total pain in the arse. It's horrible. And that's, you know, if you've ever spent any time doing that, then that is such a great advertisement for well-documented, as like to repeat myself, a really important, but it's not just good enough that it's free and open source, it's also got to be easily available and documented so that when I go to that website, I can easily read that documentation. When I'm trying to find a new library these days, I don't look to see how capable the library is, I look to see how good the documentation is, because the library is no good to me unless I can use it. And so it's kind of funny that I was asked to do a talk on Raspberry Pi, because the Raspberry Pi isn't open source hardware, but it does run open source software. I thought I'd just put a couple of figures together. I did my best to find some things out about how this stuff is growing. This is why I asked you, Jeremy, about your figures on Arduino. So people don't know about how many Arduinos are sold because they're made by so many different people, all these derivatives, but it's definitely more than 1 million. They've been going 10 years, they just had their 10-year anniversary, woohoo. Raspberry Pi, what an amazing success story for UK engineering. In 2 years they've sold 2.5 million, and I don't know if you know, but they've just announced a 1 million kind of match funding educational fund for your educational Raspberry Pi projects. I look at forum posts and forum members as a kind of pretty useless way of gauging activity, but they're numbers. And in terms of the future, I don't know if, has anyone heard of the Novena crowdsourced open source?
I actually bought one. I was trying to buy one, didn't buy it.
Yeah, so this is this Bunny Huang, he's quite well known. He's done a lot of reverse engineering and hardware hacking, and maybe that's one of the reasons why he's so into open source hardware and software. And this is a fully open source hardware and software. All the schematics, everything is available. It was crowd-funded. I think it finished 2 days ago. You could buy just the bare board for $500 or kind of buy it in a hackable laptop version. These are kind of metrically spaced threads that you can build your own circuit boards and screw them down. It's got all these ports down the side, including 2 Ethernet jacks, which is really helpful for network hackers. And really interestingly, it's got an FPGA on the board, so you can start doing really interesting things like, he was the guy who worked out there's a microcontroller on an SD card that you could then reprogram to do your own things. And he did that by using his homemade laptop that then he made available to other people. And that is really exciting, especially in this world of compromised security. I can buy something that is the closest I can ever get to trusted hardware and then run trusted software on it.
You could probably never trust that.
No. Well, it's all down to the chips, isn't it? But he because he's in China and working on the ground level with those guys, it's probably the best I'm ever going to... I didn't say perfect, but probably the best.
He's the guy who hacked the Xbox first.
Yeah, so he should know what he's doing, yeah. And Raspberry Pi, I've just made, well, not just, but recently this compute module. So this is a Raspberry Pi on a memory form factor. Don't plug it into the memory slot of your laptop. It's not like that. But this is answering this, because people are learning to use the Arduino. Arduinos end up in sold professional projects now. People are hacking and using the Raspberry Pi. They're learning this stuff, and our kids will be learning this stuff in schools. And then they can take that, load it onto a module like this, and then put that into a product where if you don't need HDMI, you don't need an SD card, you don't have to have it. So they've responded to that and made something that is going to put the Raspberry Pi into everyday consumer projects, and I think that's a really exciting part of the future as well. That it's going to, more and more things are going to run Linux. More and more things are going to just have that port on the side, so that if you want to change how it works, you can get access to it, which is much better than trying to demodulate radio waves that you've got no idea what kind of coding they're using. I think that's the end. That's the link to the presentation again, if you're interested in any of those links.